notebook paper. So as soon as you have out your notebook paper, you need to copy down these 3 rules for the properties of logarithms. So write down those 3 rules or properties. So we have the product property, the quotient property, and the power property. You will have to know these. Now, you don't have to memorize them letter per letter, but you do have to know how to use them. I don't know if they're on the formula chart or not. They might be. Okay, looking at these 3 properties, that first property, the whole purpose of these properties is so that we can do one of 2 things. So we can either take a single logarithm and break it up into multiple logs, or you can take multiple logs and put them into 1 logarithm. So if you notice, if you have 2 logs that are being added, you can change that to what? Multiplying. So notice the x and the y are being multiplied, and that's called the product. So if you have 2 separate logarithms, and notice they have to have the same base. So if you have 2 logs of the same base and they're being added, you can use the product property to make them into a single logarithm. And then for the quotient property, if you have 2 logs that have the same base and are being subtracted, you can change them to division. Now notice, x is first, it's on top in the numerator. Y is second, it's on bottom. So it's in order. Whatever is first goes up top. Whatever is last goes in the bottom. Then the last one is the power property. So if you have a variable to a power, this power just comes out front. So those are the 3 properties we'll be using. So for this first section, the instructions will be to express as a single logarithm. So express as a single logarithm, and we have 15 examples today. Number 1, we have log base 4 of 2 plus log base 4 of 32. Log base 4 of 2 plus log base 4 of 32. This is probably about the same level of difficulty as yesterday. Now, to get these into a single logarithm, notice I have the same base. This one is base 4. This is also base 4. So my single logarithm will also be log base 4. Now, if the 2 logs are being added, you use the product property, and you multiply them. So we need to multiply 2 and 32. Don't leave it like that. You need to simplify that. So this would be log base 4. And what's 2 times 32? 64. So this is log base 4 of 64. Now my answer is one single logarithm. So I change addition to multiplication. Next one, number 2. Log base 5 of 625 minus log base 5 of 25. So log base 5 of 625 minus log base 5 of 25. Now if I see subtraction, what do I change it to? Division. So this would be log base 5. So I keep the common log. So log base 5. And the 625 is first, so it has to be the top one. Whatever is first goes on top. Whatever is last goes on bottom. Does that simplify? Yes, make sure you simplify. So this would be log base 5, and what is 625 divided by 25? 25. So this is log base 5 of 25. So again, what we're doing today is not hard. Okay, 13 more examples to go. Next one, number 3. Log base 2 of 32 minus 2 log base 2 of 4. Now this one, I'm going to break it up into 2 parts. First, I see the subtraction, but I also see this 2. So if you see a number in front of the log, you need to use the power property. So the 2 out front, put it back in the exponent position. So I'm going to rewrite this as log base 2 of 32 minus. Now if you have a number in front of your log, put it back to the exponent position. So this is log base 2 of 4 squared. I can simplify that, right? Yeah, I'll wait just a second to simplify that, though. So now if I see subtraction, what do I change that to? Division. So this would be log base 2 of 32 divided by 4 squared. Can that simplify? Yes, it can, because what is 4 squared? 16. And what's 32 divided by 16? 2. So there's my answer, log base 2 of 2. No, you don't have to have those parentheses. If I still had the division, yes, I would need the parentheses. But here, the parentheses aren't necessary. But if you have them, that's fine. You're not going to get points taken off. It's better to have more parentheses than not having. Okay, next one, number 4. We have 2 log base 3 of 8 plus 4 log base 3 of 2. Okay, those numbers out front, put them back into the exponent position. That's called the power property. So the 2 goes over here, and that would be 8 squared. And the 4 goes over here, and that would be 2 to the 4th. So I'm going to rewrite those. So this would be log base 3 of 8 squared plus log base 3 of 2 to the 4th power. So the number out front becomes the exponent. Now if I have addition, what do I change it to? Multiply. So this would be log base 3, and now I need to multiply 8 squared times 2 to the 4th. And I can just put that in the calculator. Oh, I don't have my calculator up. Well, 8 times 2 is 64. 1024. Now, do I need those parentheses? No. But if you have them, that's fine. They're just extra. You don't need them. You only needed that for the multiplication or division. But once you get it down to one number, it's not necessary. Okay, 11 more to go. Number 5 gets us a third of the way. Here's number 5. Log base 7 of 4 minus 1/3 log base 7 of 8. I want you to try number 5. Give that one to a single logarithm. Okay, the first thing I'm going to take care of is the power. So this 1/3, put it in the exponent position. So this would be log base 7 of 4 minus log base 7 of 8 to the 1/3 power. Now if I see subtraction, what do I change it to? Dividing. So this would be log base 7, and then the 4 goes on top. And in the denominator, we'll have 8 to the 1/3 power. Simplify that. What's 4 divided by 8 to the 1/3? 2. So log base 7 of 2. And again, the parentheses aren't necessary once you get it down to one number. But with the division, it's necessary. Next one, number 6. Now it says to solve and check. So now we're doing some equations. These are pretty simple. So number 6, we have log base 5. In the parentheses, it's 2x minus 3 equals log base 5. In the parentheses, we have x plus 2. Now this is going to be kind of similar to those exponential equations. Because notice this is log base 5. What do you notice about this? Log base 5. And what does this symbol mean? Equal. So if these two things are equal, what do I know about these parts that are in the parentheses? They would have to be equal as well. So basically these log base 5s, they basically cancel, just like with our common bases. So now set your parentheses equal. So this would be 2x minus 3 has to equal x plus 2. So if the bases are equal, the parentheses should be equal as well. Solve for x, what would I do first? Subtract x to both sides. What's 2x minus x? So this is x minus 3. What does it equal? 2. Last step. Add 3 to both sides. And what's our answer? X equals 5. Okay, 9 more. Okay, number 7, log base 3. Inside the parentheses is 3x minus 5. That equals log base 3. In the parentheses, we have x plus 7. What do you notice about those logs? Same base, so they cancel. So what do I do with what's in the parentheses? Both of these should equal. So that means 3x minus 5 should equal x plus 7. What do I do next? Subtract x to both sides. What's 3x minus x? So this would be 2x minus 5 equals 7. What's next? Add 5 to both sides. So 2x equals 12. Divide both sides by 2. What does x equal? 6. Now, real quick, I do need to go back to this previous question, because what were those instructions? Solve and check. So if I put a 5 right here, what's 2 times 5? What's 10 minus 3? Is that a positive number? Yes, so it's good. Because make sure, remember we talked about this yesterday, this number in the parentheses can never be negative. So over here, if I put a 5, 5 plus 2, does that give me a negative? No, so make sure you check. So now we also need to check problem number 7. So what's 3 times 6? What's 18 minus 5? 13. Is that a negative number? No, so that one's good. If I put a 6 over here, 6 plus 7 is 13. Is that a negative number? No, so both of those are good. Next one, number 8. Log base 2 of x plus log base 2 of 7 equals log base 2 of 63. Okay, now we're going to combine part 1 with part 2. So what were we doing in that first section of problems? Getting them into a single log, right? So that's what we'll have to do here. So for that left side, if you have more than one log, combine them into a single log. So on the left side, if I see addition, what operation do I change it to? Multiplication. So this would be log base 2, and this would be x times 7. What's x times 7? 7x. And that equals log base 2 of 63. What happens with my log base 2's? They cancel, so what would be left? 7x equals 63. Divide both sides by 7, and what does x equal? 9. Now this time I'm going to remember to check it, so make sure you substitute in and make sure it doesn't give you a negative. Well, if I put my 9 right here, is that a negative number? No, so it's good. Next one, number 9, log base 3 of 48 minus log base 3. In the parentheses, we have x plus 3. That equals log base 3 of 8. If I have more than one log, get them into a single log. So for the left side, if I see subtraction, what do I change it to? Division. So this would be log base 3. What goes up top? 48. What goes on the bottom? X plus 3. That equals log base 3 of 8. What happens with my log base 3's? They cancel. So this would just be 48 over x plus 3 equals 8. Now to solve this. To solve this, I would probably make this a proportion and put this over 1. And then I could cross multiply. So when I multiply on this diagonal, the 8 needs to be multiplied by x plus 3, which means we'll have to distribute. Set it equal to the other cross product. And on the second diagonal, what is 48 times 1? 48. Distribute the 8. What is 8 times x? 8 times 3. So 8x plus 24 equals 48. What's next? Minus 24 to both sides. 8x equals 24. Divide both sides by 8. X equals 3. Make sure you check it. So if I put a 3 right here, what's 3 plus 3? 6. Is that not 0? Is it not negative? Is it a negative number? No, so it's good. So just make sure that number is never negative. Next one, number 10. 4 log base 8 of x equals log base 8 of 81. What do I have to do with that 4 out front? Yeah, make it the exponent. So put it back in the exponent position. So this would be log base 8 of x to the 4th power equals log base 8 of 81. What happens with those log base 8s? They cancel. So what are we left with? X to the 4th power equals 81. How do I get rid of the 4th power? Take the 4th root. So 4th root the left side, 4th root the right side. And to do that, on your calculator, hit that button by the 9. Okay, so hit the button by the 9. Oh, let me get rid of all that. Okay, button by the 9. And we want, yeah, this one right here. And we want the 4th root of 81. And what would that be? 3. Now this is technically like a square root, where technically this would be plus or minus 3. But could this be a negative 3? No. So the only answer that's possible would be the positive 3. So the only answer possible is a positive 3.
So if it's a negative, that means it does come wrong.
Well, if it's a negative, this number right here can never be negative. So the negative one would not be a solution.
Well, I'm saying, like, when you say that to check it, like, if you check it and the answer is a negative, that means you did come wrong.
No, if that's a negative, it doesn't mean that you did something wrong. It just means that that one doesn't have a solution. I mean, but if that happens to you on every single problem, you're probably doing something wrong. But if that just happens once or twice, you're fine. Okay, next one. We have log base 2 of x minus log base 2 of 5 equals 2 log base 2 of 10. I want you to try number 11. Mhm. Okay, convert those to just a single logarithm. So if I see subtraction, I change that to division. So this should be log base 2. What goes on top? Has to be x on top, 5 on bottom. This equals, what do I do with the 2 out front? Make it an exponent. So this would be log base 2, and this would be 10 squared. I'll leave it as 10 squared for just right a second. So what happens with those log base 2s? They cancel. So this would be x divided by 5 equals, instead of 10 squared, now I'll put 100, the opposite of divide by 5. Multiply both sides by 5. So that gives us x equals 500. And check it. If I put a 500 right here, does that make it negative? No. So it's just 500 for the answer. Okay, number 12. Number 12, we have 2 log base 3 of 6 minus 1/4 log base 3 of 16 equals log base 3 of x. I want you to do number 12. Okay, get this to a single log. So the 2, put it in exponent position. 1/4, put it in exponent position. So this would be log base 3 of 6 squared minus log base 3 of 16 to the 1/4 power equals log base 3 of x. Do I still have a single logarithm? No. So if I have subtraction, what do I change it to? Division. So this would be log base 3, and I would have 6 squared up top, and the bottom would be 16 to the 1/4 power. That equals log base 3 of x. Simplify that. What is 6 squared? 36. What's the 4th root of 16? 2. So 36 divided by 2 would be 18. What happens with the log base 3s? They cancel, so what's the answer? 18 is the answer. Okay, 3 more. 3 more, 3 more, 3 more. Number 13, log base 3. In the parentheses is x minus 5. It equals 2. How many logs do you see? 1. Let me go back to this previous question. Or let me go way back here. How is this one different? It had logs on both sides. But if we look at this one, number 13, it only has 1. So if you only have 1 log, you need to convert to exponential form. So if there's only 1 log, yes, do what we did yesterday. I don't know why my pen's going so slow. So only 1 log. There we go. Come on. There we go. Got the D. If there's only 1 log, convert to exponent form. Everybody thinks it's real easy, and then they get to this problem, and then they mess it all up for some reason. And what I've seen students do in the past is say x minus 5 equals 2. Is that true? No, because do we have a log on the other side? No, that's only the case if I have logs on both sides. If you only have 1 log, convert to exponent form. So for number 13, what's the base? 3, what's the exponent? 2, what does it equal? X minus 5. Then what's 3 squared? So 9 equals x minus 5. What's next? Add 5 to both sides. So what's my answer? 14. Now again, make sure you check your answers. If I put a 14 right here, what's 14 minus 5? 9. Is that a negative number? No, so we're good. 2 more. Number 14. Number 14, we have log base 2 of 4x plus 10 minus log base 2 of x plus 1 equals 3. Where do I start? Yeah, put them together to 1 log. So this would be log base 2. If I have subtraction, what do I change it to? Division. So what goes on top? 4x plus 10. What goes on bottom? X plus 1 equals 3. How many logs do we have? 1. So if there's only 1 log, how do you solve it? Convert to exponential form. So for this one, what is the base? 2. What's the exponent? 3. And this equals 4x plus 10 over x plus 1. Simplify that. What's 2 cubed? So this would be 8 equals 4x plus 10 over x plus 1. How could I solve that easily? Yeah, make it into a proportion. So this would be 8 over 1. Multiply diagonally. So for this cross product, 8 has to be multiplied by x plus 1. And for the other cross product, 4x plus 10 needs to be multiplied by 1. That just gives us 4x plus 10. What's next? Distribute that 8. So what's 8 times x? 8x, what's 8 times 1? 8 equals 4x plus 10. What's next? Subtract the 4x to both sides. What's 8x minus 4x? 4x plus 8 equals 10. What's next? Subtract 8 to both sides. So that's 4x equals 10 minus 8 is 2. Divide both sides by 4. And 2/4 is the same as 1/2 or 0.5, either one. But I do need to go back up and check that. So if I substitute in 1/2, if I put in a 1/2 right here, what's half of 4? And 2 plus 10, is that a negative number? No. If I put a 1/2 right here, is that a negative number? No. So we're good. One more. Last one. Log base 4 of 100 minus log base 4 of x plus 1 equals 1. Where do I start? What do I do first? Combine them to a single log. So if I see subtraction, what do I change it to? Division. So this would be 100 over x plus 1 equals 1. How many logs do we have? 1. So if you have only one log, how do you solve that? Convert to exponential form. So what's the base? 4. What's the exponent? 1. And this equals 100 over x plus 1. What's 4 to the first power? 4. So I'm just going to erase that 1. And how can I easily solve this one? Put it over 1, make it into a proportion. Cross multiply. The 4 has to be multiplied by x plus 1. For the other diagonal, what's 1 times 100? 100. What's next? Distribute the 4. So what's 4 times x? 4x plus 4 equals 100. Subtract 4 to both sides. So what does 4x equal? 96. And divide both sides by 4. What does x equal? 24. Check your answer. If I put a 24 right here, does that make that a negative? No, so we're good. Now on your assignment, make sure you're showing the work. No work, no credit.